Okay, so what we're talking about here is the rational root theorem and finding roots of equations if we don't have a graph. Okay, rational root theorem. You take all of the possible factors of the last term divided by all the possible factors of the coefficient of the first term. Okay, the factors of the last term. Factors of 15 are 1 and 15, 3 and 5, and that's it. So 1, 3, 5, and 15. The factors of 1 are just 1. You put all of these factors over these, and then you need a positive or a negative to that. So positive or negative 1, positive or negative 3, positive or negative 5, positive or negative 15, which is this one right here. And then it says choose the rational zeros. Okay? What are the zeros? Well, that's when you do the synthetic division. Okay? Now, if I was a guessing man, since they have multiple choice, I would guess it's probably one of these three. Okay? One of those two answers, but those three roots. Okay? So let me try a 1 first. 1 gives me 1 and 1 and 1 and 1, right? No, 2 and 2 and negative 15 and negative 15 and 0, right? Okay. So since I know it's a 1, then all of a sudden I know it's D. But if you didn't know that, this would be 1x squared plus 2x minus 15, correct? Since this was x cubed. Then I just factor that into x minus 3 and x plus 5, which would give you a negative 5, a positive 3, positive 1 for roots. Okay? For this one, the factors of 50. Factors of 50 are 1 and 50, 2 and 25, 5 and 5. Factors of 10 are 1 and 10, and 2 and 5. So the factors are 1, 2, 5, 25, and 50 over 1, 2, 5, and 10. Oh, 5 and 10. That was a mess up there. Okay. There we go. No, you're not crazy. I'm just trying to do math too fast. 1, 2, 5, 10, 25, and 50. Now you got to get all the possible combinations of these over each other. So 1 over 1, 1 over 2, 1 over 5, 1 over 10. 1 over 1, 1 over 2, 1 over 5, 1 over 10. Then 2 over 2, which is 1, 5 over 2, 10 over 2, which is 5, 25 over 2, and 50 over 2, which is 25. Okay? And then 1 over 5, 1 over 10. So it's got to be this one or this one. What's the difference between these two? This one has a 50 and that one doesn't. So it's got to be B, right? Okay. So choose the rational zeros. Well, I got to figure it's either this one or this one. So which number am I going to choose when I do my synthetic division? What would be the easiest? Out of these numbers, what would be the easiest? Probably 25. So if I go 25 and I go 10, negative 249, negative 27, 50, I'll see. 10 gives us 250, which gives us 1, which gives us 25, which gives us negative 2, which gives us negative 50, which is 0. Okay? So if I know it's 25, then I know it's choice B. Okay? Now, we're not told to find the rational zeros, and this time, now we got to figure them out ourselves, not have multiple choice to help us out. Okay? So what are the possible rational zeros for this? Well, for 35, it's 1, 5, 7, and 35, right? For 3, it's 1 and 3. So generally, when we're doing this, you always try 1 first. So it kind of sets up where you're at. So it's 3, -5, -21, 35. Okay? So 3 gives me a 3, a -2, um, a -2, a -23. Not going to work, will it? Then we try -1. 3, -5, -21, 35. 3 gives us a -3, a -8, an 8, a -13. Not going to work. So then we have to try a 3 and a -3, and we just keep going. Okay? Oh, not a 3, because 3 would be on the bottom, so it would be 1/3. But I'm not going to try 1/3. I'm not going to try fractions yet. So I'll try a 5. 3 gives us 15, which gives us 10, which gives us 50. What's 50 minus 21? Like 29? And that doesn't work. We try -5. 3, -5, -21, 35. 3 gives us -15, -20, 100. Not going to work. Okay? We could try 7. 3, -5, -21, 35. 3 gives us 21, 16. Really big number. Is it going to work? Is it going to work? No. Okay? Because our numbers get too big. If I try -7, I think our numbers are going to get too big, so will 35. Okay? So the last thing I can try is 1/3 and 5/3 if I am really working hard at this. So 1/3 of 3, -5, -21, 35. What's 1/3 of 3? 1, which gives us -4. And then we get ugly fractions. Probably not going to work. Let's try a -1/3. To give us -1, -6. Ooh, -1/3 of 6 is +2, which gives us -19, which is then ugly fraction again. Okay? So if you keep going through there and look, it doesn't look like we have much. So what I'm going to do is cheat. How do we cheat? Well, I'm going to graph it. That's how I'm going to cheat. So it is x cubed, right? Or is it 3x cubed? 3x cubed, right? Sure. 3x cubed. And then it was minus 5x squared, right? Minus 5x squared minus 5x squared minus 21x plus 35. Okay, so it crosses somewhere in between -2 and 4, but not at -3. Somewhere in between 0 and 2, but not at 1.67. It crosses 2.646. So 1.67 is 1 2/3, which is 5/3, right? Which is just enough information to help me out. So if we have 5/3 here, because the graph said 5/3 will work, let's see what that does for this. 3, -5, -21, 35. 3 gives us 5, gives us 0, gives us 0, gives us -21, gives us -35, which gives us 0. Okay? Which gives us 3x squared minus 21. equals 0. Can we factor that? Yeah. Take out a 3, and it's x squared minus 7. Does x squared minus 7 factor? No. Okay? If you said equals 0, if you divide by 3, x squared equals 7, so x equals plus or minus the square root of 7. Square root of 7 is an irrational 0. So the rational zeros are 5/3. The irrational zeros are square root of 7 and negative square root of 7. Okay? So this one, okay, should we cheat again? Okay. So it's x to the fourth minus 5x to the third. So if we go x raised to the fourth is minus 5x to the third. And then what else do we got going on here? Minus 8x squared plus 10x plus 12. Okay, looks like we cross here at an ugly number, -1, 0, an ugly number, 6, 0. So -1 and 6 should be answers, correct? So if we do the synthetic division on this, -1 I know is an answer, and I go 1, -5, -8, 10, and 12. If I do this quick, 1, -1, -6, 6, -2, 2, 12, -12, 0. I knew that one was going to work. I also know a 6 will work from the graph. So 1, 6, 0, 0, -2, -12, 0. So what I'm left with is this is x to the fourth, this is x to the third, so this is x squared minus 2 equals 0. Okay, so I solve it. X squared equals 2. X equals plus or minus the square root of 2. So the irrational zeros are square root of 2, negative square root of 2, and our rational zeros are -1 and 6. So if you graph it to find the rational ones, do synthetic division, and then do factoring to find the irrational ones. That would be the easiest thing to do. 4 problems. I'll let you get going on that. And then, like I said, we will have a quiz review tomorrow and a practice quiz, and then quiz on Friday. Okay, that's what's up the rest of the week.